Let's move to the next point where we will try to understand these numbers. Basically, what are these numbers, what actually it represents, how it calculates this number of rows, why full table scan comes first, why different kind of scan is being applied on different entities, what is nested loop join algorithm, and how this final query cost is getting evaluated, right? So there are like many points to learn or understand. So first is why full table scan on orders table but not on others table. Second, why we have, more number of rows somewhere here, less number of rows somewhere here. What are these numbers, and why do we see one row here but 9 rows here, right? Something like this. So we will try to cover each of these points, and that is what our one of the topics was, like understanding each of these components, these parameters, to know how this query cost is getting evaluated. And this is very important for us, and this is what one of the primary objective of this session is, where we have to understand all of these parameters so that we can decide to optimize, or we can find a way to optimize our query, right? Since we have this input, now if you look at the diagram, right, it says that nested loop, meaning it is going to perform a for loop on the number of rows that it fetched after performing the full table scan. I'll come to this full table scan, why it is happening. But now let's try to understand the workflow first. So what we are trying to understand here is we are trying to understand this specific workflow that got resulted after running the explain statement, right? So now first point is clear, I'm hoping, like why it has picked the order table even though it is performing the full table scan. The reason is the query cost, even though after performing the full table scan, is lesser than the other tables. Hence database has decided this table to use as an entry point. Now the next step, nested loop, right? So whatever the records we get after performing the scan on the orders table, which has the exactly 326 record, hence it has picked all the records, and it will perform the for loop on this, okay, on this specific case. So he's saying nested loop because it is going to loop each of the records, and for each record it is going to query the customer table. Now for each of these record, if you go and query the customer table, we are going to get the 326 records, hence it produces the output as 326 records, right? Now let's try to see that, right? Let's try to see that in action, whatever I'm explaining it here, okay? So what I'll do is I'll basically write a query. Let me comment this out. Write a query, select star from customer table, right? So for each of the record, it has to go and query the customer table, correct? So what I'll do is select star from orders table, where now what is the relation between orders and customer? It's a customer number. So I'll say o dot customer number, where sorry in okay. So here what exactly whatever you see in this diagram, right, at least at this stage focus on at least this portion, and that is what I'm trying to do it here. So select star from orders, where I'll be getting all the 326 records. For each of them I'm going to query the customer table, okay? So I'll have to fetch the customer number here, LCC where C dot customer, okay, sorry, that's right. Now if you look at the output of this query, we are going to get this. Okay, let me run this in the separate tab so that this diagram will still available for us to use. And for that, new tab, then open it and run this. Right? See, you are getting 326 record, and hence in your evaluation diagram, which is produced by the explain statement, you see 326 rows as output. Right? Now, question is, what is this one row represents here? And what is the unique key lookup? Okay. Now for that, I would like to again switch to the, even I don't think we have to switch. If you hover on this, right, you see the access type equals to EQ underscore REF. I think there is some problem in the MySQL workbench where the this output is getting trimmed out. But if you look at right, access type is equals under sorry EQ underscore REF. So for better output, what we can do is we can switch to tabular explain and see it here. See, this is a simple select type on customer table. What kind of join is happening here? It's a EQ underscore REF. What exactly this means is, so this says that the reference table where you are trying to join, if you are trying to, in the reference table, if you are trying to join using the primary key, in that case, the type that will get applied will be EQREF, and it will perform the unique scan. Okay, I'll summarize. If you see the type as EQ underscore REF, that says that the reference table, in this case, what is the reference table? Customer number, right? The reference table, if you are trying to join using the primary key, which is the primary key or not null unique index key, then only this type is getting applied or will be applied. Okay, so in this case, customer number is the customer table is the reference table where we are joining with customer number, which is the primary key in customer table. Hence it is performing the unique index, meaning for each of the customer number that we have in the orders table has the uh, unique record available in the customer table. Okay, now let's go and look at the customer table. Like if you go to customers table, so let's go to customer table. Sorry, yeah, I mean, if you look at the customer tables and index, the primary key is created on the customer number, and that is what we are using for joining. Right, now let's look at the data. If we look at the data, we have 122 row only. Right, now you may ask, okay, because it has only 122 row and we are getting the output as 326 rows. Why? If you look at this, we are getting 326 rows as an output. But why so? Okay, let's try to understand that part as well. Now if you look at the orders table, select star from orders. Right, if I run this query, I'll be getting the certain distinct customer number, and when I pass this customer number to this query, right, when I pass that customer number to customers table, it is, your database is able to uniquely identify that specific record. Right, hence it is performing the unique key lookup. If you look at the orders table and try to fetch the distinct customer number, let's see how many records we get. We get 98 records, right? So with this analysis, what database is trying to do here is basically for each of these 326 records, there are distinct, or there are unique 98 records which are present in this customer table, which is uniquely identifiable. Hence, it is performing the unique key lookup, right? And for each of that record, it exactly returns one row. Hence, it is showing one row. Here in this case, it is happening like it is returning, 9 row on an average. Hence, it is showing 9 rows, right? And it is showing non-unique key lookup. I'll tell you why. Because whatever the indexing we have on the order details table and the attribute that we have used in our where clause, the only partial index is being applied. Hence, it is performing the non-unique key lookup. And for each of the condition, it is not able to identify the records uniquely. Meaning, when I pass one condition, for that specific condition, it is fetching more than one record. That tells us that specific condition is not able to fetch the details from the target table uniquely, right? Hence, it says non-unique key lookup. And on an average, the number of rows that gets returned is 9 rows, right? Coming to this one, since we are performing the scan on each of the 326 records, it's like nested loop join algorithm. That is what it says. So for each of the 326 records, it will go and query the customer table. And since we are passing the customer number here, and if you look at this, right, we are passing the customer number here from the orders table, right, which has the distinct 98 customers. So it will fetch all the details from the customer table, and it produce the output. And the output is basically 326 rows again, because we are iterating over the 326 records, right? Let's assume the case where you have like more number of records in the customer table, right, with the additional customer number. Then definitely it will be filtering out only those customer number which are available on the orders table. I hope it is clear. Now we are clear with this number of rows and why this one row. Now what about this 114.1 and 148.57? So when each of these 326 records gets iterated and pass it to the customer table, right, to evaluate that part or to evaluate that query output, database evaluated the cost as 114.1. Means this is the number which it identifies while executing the query for each of these 326 records. Hence it says 114.1. Now the cost that we have seen at the first stage is 34.48, and here 114.1. Now if you sum it up, it will give you 148.57, right? I hope this two part is clear. Now moving to the next part. Since we have still 326 records, now it has to again iterate through all of these 326 records, but where? On order details table, it has to now iterate over. Okay. Now when we iterate over on order details table for each of these 326 records, again same concept as we have seen earlier. It has to perform the scan on order details table, right? And in order to perform the scan or execute the query, database has evaluated that as 388.95 as a cost, and if you add this cost to this number, you will be getting 530.52 cost. So at this stage, the total query execution cost is 530.52. Now question is, okay, here we were having 326 record, but now suddenly it got bumped up to almost 3k rows, right? So now let's see if you are getting 3k rows when we iterate over all these 326 records on order details table. So same as now, let's go to order details schema first, right? And if you look at this index, primary key is on order number and product code, right? Primary number is in order number and product code. But are we applying these two keys as a combination in the query? If you look at here, no, right? In the order details table, we are not doing that. Hence, it is performing the non-unique key lookup, right? Because the combination of these two key, unless you pass to that table, it is not going to find the unique record, right? For some, it may return 1. For some, it may return, let's say, 3, 4, 5, whatever the number, based on your data set. And hence, in this case, you see 9 rows. I'll repeat. In this case, order details table has a composite primary key with the combination of order number and product code column. And with this combination, we are not applying that in this query. Hence, when database iterates over these 326 records on order details table, it doesn't produce a single record. Right? It doesn't identify the record uniquely. Hence, it says here 9 rows and takes more time than this one. If it is a unique key lookup, I'm 100% confident that the here it would show as 1 row, and the cost will be definitely lesser than 388.95 with the data set that I'm using it here. Right now, let's evaluate, okay, why these 3k rows appearing here. Okay, so for that, let's go to the order details table and see how many records we have. So if you see here, we have almost 3000 rows appearing here, right? Now, what is the relation between order details table and orders table? So it's like select star from orders order details OD, where O dot order number equals to OD dot order number. Now if you run this query, see how many records you are getting. So we are getting 2996 record, right? Now if you perform the distinct on see how many you are getting, 326 record. So what exactly this two query tells us? This query tells us that whatever the order number we have in the order details table, all those order number is also present on orders table. Hence, when we iterate over order number on order details table, it gives me the 2996 record, and that is being evaluated as almost 3k rows. It's like nearly 3k rows. It's not exactly 3k rows, right? Now if you try to again like find out, okay, in order details we have 2996 rows, but here we are getting like 326 distinct order number. That means in the order details table, for each of the order we will be having multiple entries, right? Like for each order there will be multiple order details. Hence we are getting 2996 records. So let's write a query like order number, just to see how many order for a given order, what is the exact order details we have present in the order details table. Okay, so I'll just group by order number so that we'll get the count as well. Now if you look at this, right, see, for each of the order we have multiple order details present. Now if you sum this, or now if you sum up this count, right, you will be exactly getting the what 2996 records. So I'll say select sum of count from right? Say 2996. So to summarize, for each of the 326 records that we see in the orders table, when we iterate that on order details table, which has all those 326 records present with multiple orders, right, that led to total number of records count, which is 2996 on order details table, which is nearly 3000 rows, and that is what we see as part of this nested loop scan output, right? So I'm hoping you guys are with me and it is getting clear each of these stages, right? Now, how will you know if non-unique key lookup or non-unique key scan is happening? Again, if you switch or mouse over on this table, right, if you look at the access type, it is saying reference. It's like REF, referential access type is happening, okay? It is not performing the unique key lookup that we have seen in the previous case. So in your case, if you're evaluating or analyzing any query performance for your case, and if you are seeing the access type as like EQ underscore REF or REF, right? That means it's not like bad thing. It's definitely a good thing. Again, depends on the use cases. So if you have like this kind of use cases, then it is fine, you know, because even if you look at the cost hint, right, it says like low, medium. In this case, it just say low. In this case, it will say very high. Why? Because full table scan is happening. But here in this very high is also like very low, kind of very low, because we have the less number of record. But if you have like, let's say, millions of record, it is definitely going to impact your query performance. Now coming to this 3k rows output is clear now. I'm hoping that, right, like from where it is coming and from where this 532.52 cost is coming. Now we have this 2996 rows or records. Now that will get applied over the products table. So far we were performing the or we were looping over the 326 records, but now we are going to loop over 2996 records on product table. And if you do so, we'll be ending up seeing the 2996 records as an output. But in this case, again, it is doing the unique key lookup. Why? Because we are making use of product code, and that product code is getting applied on products table. And if you look at the product table structure, product code is basically a primary key. If you go to see, this is the primary key, and index is also created on product code only. Hence, when we apply or iterate over this 2996 records on products table, now whatever the number of products we have, with that product code, when it goes to products table, it is returning only one product entries. Hence, it says unique key lookup, and here it says one row. And in order to evaluate this entire products table for each of these 2996 records that we have seen the output at this stage, it costs around 1048.6. and now when you sum this up with this number, then you'll be having the final output or final cost as 1579.12, right? And it will also produce 2996 records. So let's see that case as well. So I'll go to products table, and now if you go to products table, right, you'll see 110 record, right? Total number of record is 110. Now let's go and query the distinct of product code on order details table. See, we have 109, and in products table we have 110. So it's like for each of these product code, you know, it is uniquely, our database is able to identify the records uniquely, and hence here it says one row. Now again, the same case, if we have like composite primary key created for on this table, right, and again we'll be doing that as well. and if we have that composite key created, and if we apply this case, I mean if we rerun this query, we may not be seeing the unique key lookup here. Okay, we'll be seeing only the non-unique key lookup, but the query cost performance may not be increasing with the larger number, because as I mentioned in the beginning, right, the sample database schema which I'm using is having the less volume of data. But if you're dealing with like more volume of data, definitely it will show the more costing if unique key lookup is not happening, right? So I hope this entire flow is clear. Now let's try to validate each of the cases that I have mentioned, like switching from unique key lookup to non-unique key lookup. As I said, I don't think the costing will increase because of less volume of data, but let's see that. Okay, uh, let's try to look at the first use case where I'll be adding the additional key. Basically, I'll be making the composite key on the customer table, and we'll rerun the explain analysis, and we'll see if it is performing the unique key lookup or non-unique key lookup.